Hello class, I'm creating a video to help with the last few problems in your Module 8 homework. This question says, use the formula for present value of an ordinary annuity or the amortization formula to solve the following problem. So here is the formula for present value of an ordinary annuity. I believe you can find that in your formula sheet. And we're given PV. We know this value here is 20,000. We're given the payment, PMT, which is 300. The only thing we don't know is the value for N, right? So we have to solve for N. So I can plug everything else in here and solve for N. So let's do that. I'm going to write this out on the whiteboard. So I've written this out. You have to forgive my handwriting. I'm writing on a tablet, and I'm getting used to my the stylus. So again, we were given all of the values except N, so I want to plug in my values for N, right? We were given PV, I, and PMT. So I'll just plug those into my formula. Let's see here. All right, so PV was 20,000. PMT was 300. And that's going to be times 1 minus 1 plus the I was 0.01 raised to the negative N, which is what we don't know. And this was all over 0.01, right? I is the 0.01. So what can we do to solve this? Well, there are a few things we can do. I'm going to pull out my calculator. So the first thing I could do, I could divide 20,000 by 300. Right, so here's my 20,000 divided by 300. I get an answer. So now I'm going to have 66.667. All right, so we're left with something that looks like this. The next thing I can do is to get rid of the 0.01. If I multiply both sides by 0.01, these will cancel, and then I'll have an easier time to access the N. So in my calculator, I want to multiply that 66.667 times 0.01. So really that just had the effect of moving the decimal 2 places to the left. So it's now 0.6667. So now the next thing I have to do is if I subtract this 1 from both sides, right, so I'll call this step 4. I'm going to do the 0.6667 minus 1. It's going to give me a negative, which is okay. So I have negative 0.333 equals negative 1 plus 0.01. You see we're getting closer and closer to getting this value by itself, getting N by itself. Now, if I multiply both sides by negative 1, this becomes positive, and this becomes positive, right? If I multiply both sides of the equal sign by a negative, or a negative 1, I can change both sides to a positive. And now the last thing I need to do, I can either graph both sides of the equal sign and get the intersection, or I could use logarithms to finish this problem, right? If I take the log of both sides, right, equals log of 1 plus 0.01 raised to the negative N. The properties of log say I can actually take this negative N and put it in front. So I'd end up with something that looks like this, log 0.333 equals negative N times 1 plus 0.01. We're almost done. I forgot the log. Let me fix that. Right, the negative N goes in front of the log, and then it's 1 plus 0.01. And now to finish the problem, divide both sides by log, 1 plus 0.01, and we're almost done. Right? So this is going to cancel, leaving me with log 0.333 over log 1 plus 0.01, and that equals negative n. Okay, so let's do that in our calculator. Let's see if I can move this over in the spot you can see. So I'm going to do log 0.333 divided by log of 1 plus 0.01. Close that. I get an answer. So it looks like n is going to be equal to that 110, right? So my final answer would be negative 110.510 equals negative n. Again, if you multiply both sides by negative 1, you end up with something like this. Right? So now let's see what they were looking for in terms of rounding. All right, so if I minimize this, round to the nearest integer. So that would be 111. Right? So n equals 111. Right? Because if you remember, we got 110.51, so the nearest integer would be 111. Check answer, and we get the well done next question. I hope you found that helpful. Look for my next video to answer the next problem. Thanks for watching.